It's a wordy question which, to me, gives a slight advantage to the mechanics people because they're used to sort of wordy questions with differentiation and calculus in it. We've got at any time t, the rate of increase of a population. So there we go, the rate of increase of a population. The population is n. So the rate of increase is how n changes over time. So the rate of increase of the population, that will be dn dt. And it says that is proportional to the size of the population, which is n. So that first sentence comes down to that notation. The rate of increase of the population is proportional to n. What do we do next? If we see a proportional sign, what do we change it into? Yes, that's right, kn. So we change that proportional sign into what? In equals k times by. So what's happened there is the proportional sign has been replaced with equals k times by. Okay. So we have that differential equation. Okay. We've got a differential equation. What do we do? What's the first thing? I don't want Corey to answer this one, I want someone else to answer. First thing we do once we've got our equation?
Separate the variables.
Separate the variables and integrate. Yeah, okay. Keep the n's on the left because the dn is there at the top. So any t's on the other side. Well, that n then needs to come down here. Might as well leave that where it is. Put the dt there. Separating the variables and integrating. So over here, if you want to rewrite that like that, on the left you can do, if you feel that makes it easier. What do you get if you integrate 1 over n? Front row please. What do you get if you integrate 1 over n? Yep, log of n, that's right, natural log of n. On the right, integrate k with respect to t, kt. I finish my integration, stick my plus c sign in there. Right, now, we want to get n as the subject of that formula really, not log of n. So if I want to move from a log of n there to an n equals line, what do I need to do?
On the other side, e to the k.
Yeah, I'm anti-logging, if you want to sort of think of it in words. Yeah, I'm anti-logging, okay? And you're exactly right, Sam. Over here, I will do e to the whatever is there on that side, okay? So, you could leave your formula like that, but often, if you've got e to the something plus something, a little thing is done, and it's useful that you know it. So if you look at a mark scheme, you can work out, well, hang on, what on earth have they done there? Using the laws of indices, just do something over here. Think you're in year 9 a minute, when we've just done laws of indices. What is a to the m plus n the same as? Sunny, can you remember where might that have come from using laws of indices when you're in top set year 9?
Times them together.
Yeah, so that has come from that. That is the same as that. Okay? So over here, I can say, well, that's the same as e to the kt times by e to the c. Remember, c is just a number. It's a constant. It's a number. So e to the c is also just some number. So what often happens is they say, well, let's call e to the c be big A. And then, instead of having that, you can say, well, that's e to the kt times by a, which is normally just written as a e to the kt. And if you look through mark schemes and things, if you've got that and they've got this, it is the same thing. And you just need to realise that. What they have done is just use the laws of logs over there. So that's what n is equal to. So we've now got a formula for n. We've still got this k in here, which we'll have to work out what that is in a minute. We all right so far?
Sorry, did you do that?
So, going to the question, what information do we know? We know the initial population is 50. What does initial tell us? We had it in the last question.
0.
What 0?
T.
Yeah. The initial population means t is 0, and it said the initial population is 50. So that means big N is 50 when t is 0. So if we substitute that in, we get 50 equals a e to the k times by 0. This will be e to the 0. E to the 0, Laura, what's e to the 0?
1.
1. Yep, so that's 1. So this is a times by 1. So in other words, we have just found out that a is equal to 50. So that formula there can be rewritten as n equals 50 e to the kt. So we got rid of one of the letters, we got rid of the a, we've still got that k in there. Do we have any other information we could use in the question to substitute in and work anything out? If we have a look at the question, is there anything else we can extract from the question?
T equals 1 when n is 100.
Right, t equals 1 when n equals 100. So if we substitute that in now, I get 100 equals 50 e to the k times by 1. Substituting that in. So, well, bring that 50 over there. Over here I've got e to the k. Well, that's 2. So I've got e to the k equals 2. What can I then do to find out what k will be, or what will k be equal to then?
ln2.
Laura, ladder?
ln2.
Yeah, log of 2. That's right. So now I know what k is. Then that formula box up here I had, I can change it again, improve it, and I can change now my 50, my case rather, to be log of 2. Any comments on that line I've just written down?
H. Oh, so ln.
So that's my ln. Any comments on that?
You can simplify it.
I can simplify it. How can I simplify it? What can I simplify?
The same law of indices. So you can have e to the ln2 multiplied by e to the t.
Okay, just look at that first bit first of all. Just look at that bit there. It's 2. Yeah, remember that e and log, inverse functions like cancel each other out if you want to think of it. What is in that box is just 2. So I get 50 times by 2 to the power of t. Okay, and that is a even easier and better to use formula for what we're doing here. Okay. Final bit of the question, because we haven't got there yet. It says find the size of the population when t equals 5. Final bit of the question, t equals 5, substitute that in. We get 50 times by 2 to the power of 5. 2 to the power of 5, 2, 4, 8, 16, that's 32. 50 times by 32, we can all do that in our heads, can't we? 1,600. Okay, so the size of the population at the end, 1,600. So, if I go through where I allocated marks for this question, I gave a mark for that line there, getting the differential equation. I gave a mark for separating the variables, and I gave a 2 marks then for getting 2 marks for getting down from there to here, so a method mark and there. So if you've got to that point, you're on at least 4 marks. I gave a mark for getting the A was 50. I gave a mark for getting that line down there, the e to the k was 2. And I gave another mark for getting that formula down there, which means if you're there you should now be on 7 marks. Sorry you couldn't see that one at the time. And then I gave one more mark for getting to the end of the question with the answer right. So that was an 8 mark question altogether.